The National Electrical Code, or NEC, addresses issues related to medium voltage and high voltage cable through various technical committees and associated organizations. The NEC Technical Correlating Committee, or TCC, is chaired by Paul Dabrowski. His email is and his phone number is 802.254-350. This committee plays a crucial role in coordinating and ensuring consistency across different sections of the NEC. Additionally, the NFPA Technical Committee on Electrical Equipment, chaired by Wilson Floor, addresses specific aspects of electrical equipment relevant to medium and high voltage applications. Wilson Floor's email is and his phone number is 617.984-7277. Their work involves developing and updating code requirements for electrical equipment to ensure safety and compliance. Several organizations are deeply involved in addressing medium voltage, or MV, and high voltage, or HV, cable issues. Firstly, the Institute of Electrical and Electronics Engineers, or IEEE, particularly through its Power and Energy Society, or PES, has a significant presence. The IEEE Cable Working Group within the PES focuses specifically on cable-related standards and practices. The IEEE provides a forum for experts to collaborate on research, standards development, and dissemination of knowledge related to power cables. Secondly, the National Electrical Contractors Association, or NECA, is involved as they represent electrical contractors who install and maintain MV and HV cable systems. NECA provides training, resources, and advocacy for its members, ensuring that installations are performed safely and in accordance with the NEC. Thirdly, the Independent Electrical Contractors, or IEC, also plays a role representing independent contractors in the electrical industry. Like NECA, IEC provides training and resources to help its members stay up to date with the latest codes and technologies. Fourthly, the Electric Power Research Institute, or EPRI, conducts research and development related to electric power systems, including MV and HV cables. EPRI's work helps to improve the reliability, efficiency, and safety of power delivery systems. Fifthly, the Center for Advanced Power Systems, or CAPS, at Florida State University is a research institution focused on advanced power systems technologies. CAPS conducts research on topics such as cable insulation, fault detection, and grid integration of renewable energy sources. Individual experts also contribute significantly to the understanding and resolution of MV and HV cable issues. One notable expert is Dr. Paul M. Anderson, Professor Emeritus at North Carolina State University. Dr. Anderson's email is and his phone number is 919.515-5469. He has extensive experience in power system analysis and protection. Another expert is Dr. James L. Kirtley, Professor of Electrical Engineering at the University of Illinois at Urbana-Champaign. Dr. Kirtley's email is and his phone number is 217.244-6446. He specializes in electric machines and power systems. Additionally, Dr. Victor W. Snyder, President of Snyder Electrical Engineering Consultants, is an expert in the field. Dr. Snyder's email is and his phone number is 804.274,576. He provides consulting services related to electrical engineering and power systems. To further explore this topic, several additional resources are available. The NEC Technical Correlating Committee, or TCC, website provides information about the committee's activities and responsibilities. The IEEE Power and Energy Society, or PES, website offers access to technical papers, standards, and other resources related to power engineering. The National Electrical Contractors Association, or NECA, website provides information about training, resources, and advocacy for electrical contractors. The Independent Electrical Contractors, or IEC, website offers similar resources for independent contractors in the electrical industry. Understanding how the NEC addresses medium and high voltage cable issues involves considering various factors. Firstly, cable construction and materials are critical. The NEC specifies requirements for cable insulation, conductor size, and shielding to ensure that cables can withstand the operating voltages and environmental conditions. Secondly, installation practices are also important. The NEC provides guidelines for cable installation, including burial depth, support structures, and separation from other utilities to prevent damage and ensure safety. Thirdly, protection and grounding are essential. The NEC requires that MV and HV cable systems be properly protected against overcurrents and ground faults, using devices such as circuit breakers, fuses, and grounding conductors. Fourthly, inspection and testing are necessary. The NEC mandates that MV and HV cable systems be inspected and tested during installation and periodically thereafter to verify their integrity and performance. Medium voltage cables typically operate in the range of 2400 volts to 69,000 volts. High voltage cables operate above 69,000 volts. These voltage levels require special considerations for cable design, installation, and maintenance. The NEC addresses these considerations in various sections, including Article 310, dealing with conductors for general wiring, and Article 399, dealing with outside overhead conductor installations. Specifically, for MV and HV cables, factors such as insulation type, shielding, and grounding are crucial to prevent electrical breakdown and ensure safety. Cable insulation materials commonly used in MV and HV applications include cross-linked polyethylene, or XLPE, ethylene propylene rubber, or EPRI, and paper-insulated lead-covered, or PILC, cables. XLPE cables are widely used due to their excellent electrical properties, high temperature rating, and resistance to moisture and chemicals. EPRI cables are known for their flexibility and good performance in wet environments. PILC cables, although less common today, have a long history of reliable service in high-voltage applications. Shielding is used to contain the electric field within the cable insulation and to provide a path for fault current to return to the source. Shielding materials typically include copper tape, aluminum tape, or a combination of both. Grounding is essential to provide a low-impedance path for fault current to flow back to the source, which helps to quickly trip protective devices and minimize the risk of electric shock. The NEC requires that cable shields be properly grounded at both ends and at intermediate points along the cable run. Installation practices for MV and HV cables are also critical to ensure long-term reliability and safety. Cables must be installed in accordance with manufacturer's instructions and the NEC requirements. Proper cable handling techniques are essential to avoid damaging the insulation or shielding. Cables should be supported properly to prevent excessive bending or stress. Burial depth requirements vary depending on the voltage level, soil conditions, and type of cable installation. The NEC specifies minimum burial depths to protect cables from physical damage and environmental factors. Duct banks, direct burial, and aerial installations are common methods for installing MV and HV cables. Duct banks provide a protected pathway for cables and allow for easy access for maintenance and repairs. Direct burial is a cost-effective method for installing cables in underground trenches. Aerial installations involve suspending cables from poles or towers. Protection and coordination of MV and HV cable systems are essential to prevent damage from overcurrents and ground faults. Overcurrent protection devices such as circuit breakers and fuses are used to interrupt fault currents and prevent damage to cables and equipment. Ground fault protection devices are used to detect and interrupt ground faults, which can pose a serious safety hazard. Coordination of protective devices is necessary to ensure that the correct device trips first in the event of a fault, minimizing the impact on the overall system. The NEC provides guidance on selecting and coordinating protective devices for MV and HV cable systems. Regular inspection and testing of MV and HV cables are essential to identify potential problems before they lead to failures. Visual inspections can help to detect signs of damage, such as cuts, abrasions, or corrosion. Electrical tests, such as insulation resistance tests and high potential tests, can be used to assess the condition of the cable insulation. Thermographic surveys can be used to detect hot spots, which may indicate insulation degradation or loose connections. The NEC requires periodic testing of MV and HV cable systems to ensure that they continue to meet the code requirements. In addition to the NEC, other standards and guidelines may be relevant to MV and HV cable systems. IEEE standards provide detailed specifications for cable design, testing, and installation. Industry best practices, such as those published by EPRI, offer guidance on maintenance and operation of MV and HV cable systems. Understanding and complying with these standards and guidelines can help to ensure the safe and reliable operation of MV and HV cable systems. The NEC is updated every 3 years to incorporate new technologies and address emerging issues. It is important to stay up to date with the latest edition of the NEC to ensure compliance and safety. The NEC Technical Correlating Committee, or TCC, is responsible for coordinating the code-making process and ensuring consistency across different sections of the code. The NFPA Technical Committee on Electrical Equipment develops and updates the code requirements for electrical equipment, including MV and HV cable systems. The NEC provides a comprehensive framework for addressing issues related to medium and high voltage cables. By understanding and complying with the NEC requirements, engineers, contractors, and facility owners can help to ensure the safe and reliable operation of electrical systems. Furthermore, staying informed about industry best practices and emerging technologies can enhance the performance and longevity of MV and HV cable installations. In conclusion, navigating the complexities of medium and high voltage cable issues within the NEC requires a multifaceted approach. It is crucial to understand the roles and responsibilities of various committees, organizations, and individual experts involved in the development and implementation of electrical codes and standards. By leveraging the resources and expertise available, stakeholders can ensure that MV and HV cable systems are designed, installed, and maintained in a safe, reliable, and code-compliant manner.